All right, good morning and welcome to lab. I'm going to go ahead and start with an intro to what we'll be talking about today in terms of dummy coding, contrast coding, and effect coding. And then we'll load the data, and then I'll talk about the data for a second, and then we'll jump into the full example. All right, so these materials were taken again from Leona Aiken's regression course. She's a retired quant professor that worked here at ASU for like 30 plus years. And she's the author of a multiple regression book. And so the data set here that we'll be working with is taken from Angela Bryan from the University of Colorado. And what she was studying was the intention to use condoms as a function of the attitude toward using condoms. So intention based on attitude. So let's go ahead and read in the data, and then I'll show you, and then I'll talk a little bit more about the variables. So the data, again, is in fixed width format. And remember, to read in a data set like this, we'll need to count how many spaces each variable takes up. And that will be our width. So here, the first variable is 1, 2, and then 3 spaces. The next variable is 1, 2, 3, 4 spaces. The next one is 1, 2, and then the last one is 1, 2, 3, 4. So here, when we're reading in the data, we're going to call the data set my data. We'll use the read.fixed width format, so FWF. We'll use that function to read it in. On my computer, I put it in the datasets folder. So on the C drive in the datasets folder, the file name is example10dtr.txt, so ex10dtr.txt. It's a text file. And then this is what we just went over. So here are the widths. So the first variable is 3, 4 for the second, 2 for the third, and then 4 for the fourth. Here are the variable names. We have subject number, attitude, gender, and intent. And then a couple of final options here. There's no header. And then we don't want to skip blank lines. So those are both false or F. I'll go ahead and load ggplot first, and then we'll load in our read in our data. All right, so if we take a look at this data set, again, we have 4 variables, subject number, attitude, gender, and intent. So gender is a categorical variable. Females are coded 0 and males are coded 1. And then attitude is continuous. And we'll be centering at the mean for this, for the whole sample. And I'll talk a little bit about that once we get into the example. And then we have intent here, which is also a continuous variable. All right. So for this example, we'll not only be talking about coding categorical variables, we'll also be getting into interactions and probing categorical by continuous interactions when you have 2 predictors, one of which is categorical and the other which is continuous. We haven't talked much about this in class yet, but so if there's anything that you don't quite understand all the way, don't worry about it. Mike will cover it more in class. But if you do have questions that are burning, just put into the chat, and then I'll do my best to answer those questions. Okay, so, and interactions are similar to what you may have learned in ANOVA. So, does the effect of one variable depend on the level of another variable? Okay, so what we're going to do, we're going to get into the example now. And then there's a bajillion interpretations that we're going to go over. And so I'm going to use this PDF here that I'll be posting online after the lab. This is the one for SPSS, but the interpretations are the same regardless of the program that you're using. So this is a really good resource. This is a really good reference for how to interpret these different regression models that we're going to be running. So I'll be referring back to this throughout the lab. And that way I don't inevitably make any mistakes when interpreting these different coefficients. Okay, so we'll start with frequencies. We want to see how many we have in each group here. So I'm going to create an object called freq, and then I'm going to use the table function on my data And the variable, which is indicated by this $sign here, that I'm interested in is gender D, which I'll just be referring to as gender. And then to print the object, I'm just going to run the object name. So here, remember that females are coded 0 and males are coded 1. So we have 89 females and 78 males. Okay. And then this here, don't worry too much about this stuff. This is for ggplot. This is just, this is to get our plots to look more APA style. So you could just run that chunk of code. Make sure you run this before plotting in ggplot2. All right, so we'll go ahead and start with a scatter plot here to visualize our data. So I'm going to create a plot called plot1a, and using the ggplot function, which is in the ggplot2 package, I'm going to, from my data, I'm going to plot attitude on the x-axis, and I'm going to plot intent on the y-axis. I want the colors to differ by gender, and I need to make sure that I specify that gender is a factor, or in other words, that it's categorical. So it's a grouping variable. And then I want the points on the scatter plot. So I'm going to use geom_point. So we'll go ahead and create that. And then here for plot 1, which is a new object, I'm going to use plot1a, which we just created. We haven't seen it yet. I'll just go ahead and plot it. So here's the initial scatter plot. It's not finished yet, but this is just what it looks like. So we're going to take that plot and then we're going to add some regression lines to it. So I'm going to use the geom_smooth function. Method is LM because we want a linear model or a regression line. And then the level of confidence for the confidence bands, I want a 95% confidence band. And we'll see what a confidence band looks like in just a second. And then here, I'm specifying that I want the colors to be different, and then I'm adding a title. So we'll run this line up here first, where we add the regression lines, and then we'll finish up here to get our final plot. It's just going to take a second here. All right, and so here's the plot. We have our title, and then we remember intent is on the y-axis. That's what we're predicting. And then we have attitude on the x-axis. And as we can see, the regression lines by gender seem to be different, where the regression line for females is a little bit flatter. And there seems to be a stronger relationship between attitude and intent for males. And then these gray, these gray things here are the confidence bands. So this is essentially the confidence interval going across the values of the predictor. So before we get into fitting the actual models, any questions about the scatter plot that we have or what we're doing to visualize our data here? All right. So we'll go ahead and fit our first regression model. It's called reg1, and I'm going to use the LM function to fit a model predicting intent from gender. And the data set is my data. And then I'm going to request a summary of reg1 to get my coefficients. All right, so just looking at this table here, our intercept is significant, so it's different from 0. And then here we have our gender coefficient, which is 4.76 or 4.77 with rounding, and that is significant at the 0.05 level. And so I'm going to go to the PDF for the interpretations of the coefficient. Okay, so remember, again, this is SPSS output. Don't let that confuse you, but the coefficients are exactly the same. So what I'm going to focus on are these interpretations right here. So B1 is the difference. It's the difference or the male mean minus the female mean. Now remember that males are coded 1, so that's why it's the male mean minus the female mean. And so the regression being 4.77 with rounding, with the t-value being significant, it indicates that there's a significant difference between the male and female mean on intention. So there is a significant mean difference, which is the same thing that you would see if you were to have run an ANOVA instead. And in R, it's automatically dummy coded, so you don't have to do anything to actually dummy code the variables. They're just by default dummy coded, so that's why I had to do nothing, or that's why I did nothing before running the regression model here. But when we're interpreting the coefficients, we do interpret them as dummy codes by default. And that may change depending on the program. All right, so what we're going to do here is we're going to center attitude. Now, we haven't talked much about centering yet, but the reason why we center is to allow for more meaningful interpretations of our coefficients. And so what I'm doing here is I'm going to center the attitude variable, which is our continuous variable or our continuous predictor. I'm going to center it at the mean. Now remember, like when we're interpreting our intercept, it's the value of the predictor when everything else is 0, or it's the predicted value of y when everything else is 0. So what we're doing here is 0 on the attitude variable may not be very meaningful. So when we center at the mean, then our interpretation changes to, for the intercept, it'll change to the value of y at the mean of attitude. So that gives us a little bit more to work with there. So to center this variable, I'm going to create a new variable by specifying the data set and then a $sign to indicate that I want a new variable in this my data object here. And then I want that variable to be called @cent. So centered attitude. To center, I'm going to use the scale function. I'm going to take the original variable, which is attitude, and then I want to center it, so that's equal to true, and I do not want to scale it, so that's equal to false. Now, scaling would divide by the standard deviation, which would give you a z-score, and we don't want z-scores, we just want the variable to be centered. And then to compute the interaction term, which we'll be looking at, the interaction between gender and attitude, I'm going to create a new variable called gendat. And what we do is we simply multiply the variables together. So we get this product term. So we're going to take the centered attitude variable and we're going to multiply it by our gender variable. And again, this is a categorical by continuous interaction term. All right. Now, before we get into running the full regression model, I'm going to subset my data and look at the regression models specifically for males and then separately specifically for females. So I'm going to create a new data set called mydata.m for the males, and I'm going to subset the full data set, which is my data, and I want to subset it and include only those that are coded 1 on the gender variable. And then I'm going to run a new regression called reg2.m. And using the lm function, I'm going to estimate a regression model that predicts intent from attitude only for the males. So the data set will be mydata.m, which is our subsetted data set. Hold on. Can I not run these? All right, there we go. And then I'll request the summary to get my coefficients. And so here we have an intercept of 28.5, and then we have the regression of @cent, or we have regression of the centered attitude variable. Its effect on intention is 3.27, and that is a significant slope. And so let's get into the interpretations here. All right. So the slope is 3.27, and this is the slope of the regression of intention on centered attitude for males. And then 28.54 is the male intercept. Here's a little bit more of an explanation of why the intercept is not exactly the mean. Okay, so again, this is the slope between attitude and intention for males.
All right, Patrick, are you showing another screen that's not R?
Yeah, is it not
It's
showing?
not coming up now.
Thank you. Let me stop the share here and then. All right, can we see the PDF now?
Yep.
All right, perfect. And then let me just try this real quick. And then is R showing now?
Yes, but it's either one or the other. It's not both.
Okay, got it. Thank you. All right, so again, this is the SPSS document that I'll be posting later. I'm going to draw all of the interpretations for the coefficients from here because we'll be interpreting 11 different models. And so I want to make sure that I'm being precise with my interpretations. So here again, 3.27 is the slope between attitude and intention. So this is the slope for our attitude, our centered attitude variable here on intention for males only. Remember, we subsetted our data set and we're just looking at males. All right, so now I'm going to switch back to R, and then we'll do the same thing, but we'll subset our data set for females. So here I'm creating a data set called mydata.f, and then I'm going to subset the full data set, which is my data, just for those that are coded 0 on the gender variable. I'm going to create another object for our new regression model, which will be intent predicted from the centered attitude variable. And again, we're just using our subsetted data set for females here. And then I'll request the summary for our coefficients. So here we have the intercept of 24.16, and then we have our slope here for the centered attitude coefficient, which is 0.756, and that is significant. So going back to that PDF, if we scroll down here, we have the interpretation for that one. And so this is the regression of intention on the centered attitude variable for females. And then 24.162 is the intercept for females. And it's not exactly the mean because we have centered for the whole sample and not just for each gender separately. Okay. So here, I'm going to go ahead and plot the regression for each gender separately. This is not using ggplot, so this is just base R. So I'm going to use the plot function, and I want to plot attitude versus intent. I'm going to add some labels here for the x-axis and the y-axis, and then a title here. And then type equals n creates a plot with no data points. I don't really care about the data points. I just want to see the regression lines. So here is our initial plot, and it's just blank. I'm going to use the ab line or the AB function, the AB line function, to add a regression line for the females first. So this regression line is based on a linear model where we have intent predicted by attitude. The The data set is mydata.f, which is the subsetted data set for females, and I want this line to be red. I'm going to do the same thing for males here. So just remember the only difference here is that we're using the subsetted data set for males, which is mydata.m, and I want this line to be blue. And then finally, I'm going to add a legend. These are the coordinates for the legend, so I want it at -10 and 70. I want the legend to show males and females, and I want the color to be different. I want it to be red for females and then blue for males. And then here are some, this is the line type, and this is just more options for the legend. I am not exactly sure what CEX does, but I'm sure it does something useful. All right, so I'm gonna go ahead and plot this with the lines and the legend. All right, so as you can see, our legend here is at -10 and 70. That's where the top left corner starts. And then we have it showing a red line for females and then a blue line for males. And then we get to visualize here the different regression lines when we run the regressions separately. Now remember, when we split up our sample and we subset and we run the regression separately, we are decreasing our power because our sample size is smaller. So what we'll do next is we'll run the regressions with the interaction terms so that we can have the full power of our full sample. But we just did this to visualize. All right, so we're gonna run our next regression here, which is regression 3. I'm going to use the LM function to plot, to estimate a model where we're predicting intent from gender and attitude. So I'm going to put in both of my predictors, and I'm not going to use the interaction yet. The data set is my data. And then I'll request the coefficients here. So we have the coefficient for gender here, which is 4.44. That's statistically significant. And then we have the coefficient here for attitude, which is 1.61. And that also is significant. So I'm going to switch here to the PDF again so we can look at the interpretations. All right. So B1 is the regression of intention on attitude across the whole sample with gender partialed out. And then B2 is the difference between the gender intercepts. So remember, remember that we've centered our variable at the mean of the attitude, on the mean of attitude for the entire sample. So when we're looking at the coefficient for the intercept, what we're looking at is actually where it crosses 0. So it's right here instead of over here where we're used to seeing it visually. So remember that our interpretations now for the intercept, or when attitude is at 0, is going to be right here at the mean of the attitude variable. All right, so again, we'll look at those interpretations one more time. So
sorry, Patrick, I just have a question. When you go back to that graph, and maybe I'm just misunderstanding, what would the intercept would be the gender and female individually at that? So whatever, male would be at 30 and female would be at whatever, 18. That would be the respective quote unquote intercepts at that location for those slopes, those lines.
So it's going to be the difference in the intercept. So at 0, it's the difference between where males are on this line and then where females are on this line. So okay. It's this difference right here.
Okay.
Good question. Yeah, and please feel free to ask as many questions about the interpretations. I find myself confused almost always when it comes to interpreting all of these different coefficients, especially when you start introducing a combination of categorical and continuous variables. So again, B1, which is the coefficient that corresponds to the attitude variable. That is the regression of intention on attitude across the whole sample on average when gender is partialed out. And then B2, which is the coefficient that corresponds to gender, that's the difference between the gender intercepts. So the values of males at 0 and the values of females at 0 on attitude, it's that difference. All right. So I'm gonna move on to running the full regression with dummy codes, with attitude, and with the interaction between the two variables. So here, there's a object regression 4, which is a model that predicts intent from our gender variable, which is dummy coded, our attitude variable, which is centered at the mean, and then our interaction term, which is simply the product between gender and attitude. So I'll go ahead and run that model, and then I will request the coefficients here. All right, so for our gender variable, we have a significant coefficient. For our attitude variable, also significant, and then the interaction between them is also significant. And so we'll move on to the interpretations for these. All right. Let's see. All right, so B1, which is the coefficient that corresponds to attitude, that's the regression of intention on attitude for females only. Now remember, this is because we are using dummy codes and females are coded 0. So that is our, what is that called? It's our comparison group. So it's the regression of intention on attitude for females only. And so since it is significant, it means that the female slope is significant. B2 is the coefficient that's corresponding to our gender variable, and this is the difference between the gender intercepts. So at 0 on attitude, so at the mean of attitude, it is the difference between males and females. And then B3, which is the interaction, is the difference between the gender slopes. So it is the male slope minus the female slope. So essentially what we're testing here is, so the effect of intention or the effect of attitude on intention, does that effect differ between males and females? So are the slopes different between the two groups? Any questions about the interpretation of these coefficients?
Yeah, I have a quick question. So because we get basically significance for both of the individual slopes, would our holistic interpretation be that attitude on intention is significant for both?
Right. Yeah, good question. Okay. So the drawback of using dummy codes is that we miss out on the individual test for the male slope. So here we get the test for the female slope, we get the test between the intercepts of the two groups, and then we get the test for the slopes, the difference in slopes for the two groups. But there's no individual test for the male slopes. So what we'll do for the next regression model is we'll reverse the dummy codes so that we can get that test for the male slopes. And then once you do that, then you can conclude that the slopes for males and females separately are significant on their own. Any other questions or follow-ups? Okay. All right, so what we'll do here is we'll reverse the dummy codes. So what we'll do is we'll take 1 and then we'll subtract our gender variable from 1, and that will reverse the dummy codes. So remember that females are coded 0 and males are coded 1. So when I run this code here, and here I'm creating a new variable called gen reverse. And then, hold on, give me 1 second here. Sorry about that. Our dog was not doing what it was supposed to. All right. So we reverse the gender codes here. And so when I produce a table of my gender rev, which is the reverse gender codes or the reverse dummy codes, we can see that the frequency is flipped. So we have 89 females and 78 males. And so this is just confirming that we have indeed flipped our dummy codes where males are now coded 0 and females are coded 1. Now I'm going to compute the reverse interaction. So I'm going to take the centered attitude variable and multiply it by the reverse dummy codes. And I'm going to call that new variable, whatever this is. So gender reverse attitude. And then now I'll rerun the regression, which is regression 5. And this is a model with all of the predictors. So we're predicting intent from our reverse dummy coded gender variable, centered attitude, and then the interaction between gender and attitude, or reverse dummy coded gender and attitude. So I'll go ahead and run that and then request the coefficients. And so again, we have our 3 coefficients here, the dummy coded variable, our continuous attitude variable, which is centered at the mean, and then the interaction between the two. And then all of these coefficients are significant. So going back to that PDF, now that we've reversed dummy coded everything, our B1 coefficient, which is corresponding to our corresponding to the attitude variable, is now the regression of intention on attitude for males only. And this slope was significant. So now we can say that the slope for females, when we're looking at intention on attitude, is significant, and the slope for males is also significant. And then here is the same stuff that we saw earlier when we had dummy coded when we had the dummy codes where females were coded as 0, these are the same thing, but the sign has flipped because now we're taking the female intercept and subtracting the male intercept. And for B3, we're taking the female slope and subtracting the male slope. But our B2, which is corresponding to the gender variable, our dummy coded variable, this is again testing the difference in intercepts between males and females. And remember that those are the values of, that's the male value and the female value on the mean of attitude. So let me say that again. This is always a mouthful. So when we're looking at B2, what we're looking at is the difference between the value of males on attitude and the value of males on intent or intention, and then the value of females on intention at the mean of attitude. So this is the difference that we're looking at here, and that's the difference that we're testing for. And then B3, which is corresponding to the interaction term, is testing, is this slope different from this slope here? And so that difference is also significant. All right. Any questions about dummy codes, centering, or interactions, or anything else that we've covered so far? All right. If questions come up, please just type them into the chat, and then I'll answer them as they come through. All right, so what we're going to do now is we're going to, hold on 1 second. We're going to switch gears and move into contrast coding and effect coding. So what we're going to do here is we're going to first look at our means by the gender variable. So we're going to aggregate. We're going to use the aggregate function, and we want to look at the mean when looking at intention for each group separately. So for each gender separately, and we're using my data, and then the function here, which is fun, is the mean. So here for we're going back to the original codes. So 0 is females and 1 is males, and so the mean on intent for females is 24.08 or 09 when you're rounding, and then the mean for males is 28.86. And then what I'll start with is contrast codes. So anything, so here I'm going to create a new variable called contrast, and anything that is coded 1 for gender, which are the males, I'm going to code as 0.5. Similarly, on my contrast variable, anyone who's coded 0 is going to be recoded as -0.5, and those will be our contrast codes. And then here, I'm going to compute the interaction between attitude and our contrast codes. And so I'll be taking the product of our newly created contrast variable and multiplying it by the centered attitude variable. And then again, these tables that come up in the middle of the code here is just to make sure and check that our frequencies match with what we should have. And so we should have 89 females and 78 males. So that all checks out. All right, so we'll move on to our next regression model, which is looking at intent again, and we're predicting it from our newly created contrast variable, which are the contrast codes. And we're just going to look at that by itself. All right, so we have the coefficient here, which is 4.77, and that's significant. And so going back to this PDF, or actually it's okay, so we were looking at this PDF here, which Leona labeled as 10A, and that's for dummy codes. And now we're going to move on to this other handout that I'll be posting later online, which is 10B, and this covers contrast and effect codes. So if I scroll down to the first set of interpretations, which is where we are predicting intent from our contrast codes alone. So B1 here, which is the coefficient that is corresponding to our contrast codes, is the difference between the means on intention of the two genders. So it's the male mean minus the female mean. And then the intercept is the unweighted grand mean of the two genders. So essentially, if you were to take the two means and then just divide by 2 and use no weighting, that is what the intercept value is. So if we go back to our output in R, we can see that the difference between the means between the female and male mean is significant at 0.05. And again, that's the mean on intent. We haven't introduced our attitude variable yet. Any questions about that? Okay. All right, next we have, we're going to create reg 7, and that's going to be a model where we add the attitude variable. So I'll go ahead and run that, and then request the coefficients here. And then so we get the coefficient corresponding to our contrast codes is significant, and the regression coefficient corresponding to the attitude variable is also significant. So going back to that PDF, we'll scroll down to the next set of interpretations. And so B1, which is corresponding to our attitude variable, is the regression of intention on attitude for the whole sample of both genders, controlling for our gender variable. So on average, what is the relationship between intention and attitude regardless of gender? So that's what B1 is corresponding to. B2 is corresponding to our contrast codes, and this tells us the difference between the means on intention for the two genders. So real quick, a question in the chat. Running all these different regressions for the same data, does that not run issues of increasing type 1 error? Or is it because changing the variables with interact? Okay. Yeah, so yes. So again, as Mike has mentioned in class, this is definitely increasing type 1 error because we're running so many t-tests, but there isn't yet a good framework for controlling that type 1 error in regression. Whereas in ANOVA, we would probably be running some kind of correction, like a Bonferroni or a Tukey or a family-wise error correction or whatever. So yeah, running all of these regressions is not recommended, but the reason why we're doing it for this example is just to show how the different, how the interpretation of the coefficients changes as we add our different predictors. And one thing that I forgot to mention is that, so once you start moving into, and I'm sure Mike will cover this in class, but as we start moving into testing interactions, which is a product term, it's technically a higher order coefficient because we're multiplying two variables together. And so the B3, the interpretation of B1 and B2, which are the coefficients that are not interactions, those become dependent. And so I don't know if you've noticed, but as I'll show later with when we add the interaction, the coefficient for the regression slope is, or the coefficient for the difference between the intercepts is at the value of 0 on one of the other variables. So that doesn't make much sense right now, so don't worry about it, but just keep in mind that as we're adding interactions to our models, the other coefficients become conditional. So it's at a particular, it's not talking about the whole sample or all of the values on a variable. It's talking about one particular value, which is why we center our attitude variable, so we can talk about those conditional values at the mean of attitude. All right, so going back to these interpretations here, B2 is now the difference between the means of intention of the two genders. So it's and this is with attitude partialed out. So this is the male mean minus the female mean. And then our intercept is the intention at 0 on the contrast code. So yeah, so this intercept is a little bit like the interpretation doesn't really make much sense, but it's there for you if you need it. The main point though with when we're using contrast codes is that we want to compare the means. And so B2 is giving us the difference between those means for the two different groups. Okay. Now we're going to go ahead and add in that interaction. So regression 8 is going to be our model where we have our contrast codes, our attitude variable, and then the interaction between the categorical and continuous variable. And I'll go ahead and request those coefficients. And so our contrast codes, again, are significant. The attitude variable is significant, and then the interaction between attitude and gender is significant as well. So I'll go ahead and go back to that PDF. So B1, which is corresponding to our attitude variable, is the unweighted mean of the male and female slopes. So if we take the slopes for the two groups and then we take the mean of those and then we average them, that is what B1 is. It's the average slope across males and females. B2, which is the coefficient corresponding to our contrast codes, is the difference in the intercepts. So it's males minus females, because males are coded 0.5 and then females are coded negative 0.5. So it's the significance test is for the difference between the intercepts of the two groups. And then B3, which is our interaction term, is the difference between the slopes of the males minus the females. So this significance test was also significant. So the difference between the slopes for males and the slopes for females is significantly different. And then B0 is the unweighted mean of the two intercepts. All right. Before I move on to the next one, because this is becoming pretty mind-numbing, just remember that I'll be posting these different interpretations on online later on after the lab. You don't have to remember all of these interpretations. That's not the point of this lab. The point is that you know that these exist. And depending on what your research questions are, which I think for the most part will be, dummy codes will probably be the best for those. But you'll have these on hand so you could check which interpretations kind of make sense. And you could pick the coding scheme based on what your research question is. So it will never be the case that you dummy code, contrast code, and effect code for a single data set or for a single study. It is always the case that you will pick one of the three to choose for your own study. So remember, this is definitely a information dump. So don't worry about remembering all of these different interpretations. They'll be available for you online, and you can pick the coding scheme that best matches your research question. Okay, so yes, so I will be posting so we're going over it in R right now, and then after the lab, I'll be posting the syntax files for SPSS and SAS. There's one syntax file for dummy coding, and then there's an additional one for contrast and effect coding. The code is broken up into how the PDFs have been broken up here. So not only will I post the syntax, but I'll post these handouts. There's one for SPSS, and then there's one for SAS. And it goes into much more detail than we're going in here. So again, these are good references for when you're running these on your own. All right. Now, any other questions before I get into effect coding? This will be the last set of regression models that we'll be running here. And throughout this lab, there have been these lines for ANOVA tables. I don't find them particularly useful, but if in the case that you do need them, you could just run this ANOVA function on the regression model, and then it'll give you things like sums of squares and other things that you get in an ANOVA table. All right, so finally, we'll go through effect coding. So I'm going to create this new variable called effect. And so anyone in our original data set that was coded 1, so these are the males, we're going to recode them as 1, which now I don't understand. Oh yeah, so anyone who has a value of 1 in the gender variable will now get a 1, which is the same value for the effect variable here. And then anyone, so the females, anyone coded as 0 will get a -1. And those are our effect codes. And then I'll compute the interaction between my effect codes, so the gender variable that is now effect coded, and then the attitude variable, which is again centered at the mean. And then this table will show us that our frequencies are correct. So we have 78 males and 89 females, so that's consistent. And then we'll go ahead and run our first regression model here. So regression 9 is going to be, we're only going to include our effect coded gender variable as a predictor. And I'm sorry to say, but these interpretations make even less sense. But again, if it's meaningful for you in the future, you'll have this here. So B1 now is the effect, or is half of the difference between the means on intention of the two genders. So it's the male mean minus the female mean divided by 2. And here's a little bit more of an explanation of why that is. And obviously, earlier when we did contrast codes, the difference between our codes was 1 because we had 0.5 and negative 0.5. So that's a difference of 1. And here we're doubling the difference. So now a 1 unit change corresponds to half the difference between the means on intention for the two genders. And then B0, which is the coefficient corresponding to our intercept, is the unweighted grand mean of the two genders. Okay, going back to R, we'll go ahead and estimate the model where we have our effect coded gender variable and we are adding our centered attitude variable. All right, so here the coefficient for our gender variable is significant, and then the coefficient for the attitude variable is also significant. And going back to the PDF, so B1, which is corresponding to our attitude variable, is the regression of intention on attitude for the whole sample, controlling for our gender variable. And then B2 is half the difference between the means on intention of the two genders. So again, it's the male mean minus the female mean divided by 2. And remember, it's half the difference now because the difference between our codes has doubled. So instead of being a 1 unit difference, it is now a 2 unit difference. And then B0 is the intercept for intention at 0 on the contrast code. Again, this starts to lose its meaningfulness, but it's there if you need it. All right. And finally, we have our final regression model here where we will add our interaction term. So we're now including the effect coded gender variable, centered attitude, and then the interaction between the two variables. And then I'll go ahead and request my coefficients. All right. So the variable or the coefficient corresponding to our gender variable, that's effect coded, that's significant. Centered attitude, the coefficient for that is significant, and then the interaction term is also significant. So going back to the PDF, we have the final set of interpretations here, where the coefficient corresponding to our attitude variable is now the unweighted mean of the female and male slopes. B2, which is corresponding to our effect coded gender variable, is half the difference between the intercepts of males minus females. And then B3 is half the difference between the slopes of males minus females. So again, we have the difference, half the difference between the intercepts for the coefficient that is corresponding to our effect codes. And then we have half the difference between the slopes for the coefficient, which is corresponding to our interaction term. And then B0 is the unweighted mean of the two intercepts. So going back to a question from earlier, this is too many regressions to be running on one data set. So typically what I think you'll see or what makes most sense in practice is that you'll just run the full regression. You'll just have your outcome being predicted by your different predictors and then the interactions that you're interested in, and you'll just run that one model. But again, the reason why we go through this kind of building through the regression models where we add one predictor at a time is to show how the interpretations change and how the lower order coefficients. So when you have an interaction term, all of the other coefficients that aren't interactions will now be conditional on, will now be conditional coefficients. So that's the reason why we built up to, why we built up these different models. All right, so that's all I have for this lab. We have this little bit of code here that shows a different way of visualizing the separate regressions between the different genders. But that's there for you if you want to check it out. Are there any last questions before we conclude lab here?
Yeah, I just want to, is there supposed to be an SPSS sheet for the previous lab that you did in R about the regression or the diagnostics? Because I only see one for SAS.
Yeah, I think if, hold on, let me check. Yeah, there should be one for each. Just let me double check now so I don't forget.
Yeah, because on the student end, at least it has the R lab files and the SAS lab files, but that's it.
Okay. Let's see. So, all right. Yeah, so if you go to modules under SPSS lab files, which is really, you have to scroll down a lot. It's like toward the bottom. There's a heading called SPSS lab files, and there's an Aiken diagnostics example PDF.
Yeah, I don't know if that's not public on the student end. It's not, I've scrolled everywhere on this one. Right after, because I have the lab video links, the R lab files, the SAS lab files, example write-ups, and lab data sets, and that's it.
Okay. Let me, yeah, I'll go ahead and delete it and then republish it.
Okay.
And hopefully that'll fix it. If not, just let me know and I can just send it to you.
Okay, thank you.
Yeah, of course. And yeah, so remember, we haven't gone over interactions or centering too much yet. So that'll be something that Mike goes through more in class. The way that this example was set up, it kind of just included it. But for the next lab, what we'll be looking at is continuous by continuous interactions. So if you have two continuous predictors, how do you probe interactions between those? Any questions before we end lab here? All right. Well, thanks everyone for joining me for the lab. I'll be posting this video later on online. And then if there's anything that's not working through Canvas, just let me know and I'll try to repost stuff so that you guys have access to that. All right, thanks guys. I'll see you in class next week.